In this video, we'll look at the double angle formulas. So the identities that we'll consider in this video and the next few videos are consequences of the addition and subtraction formulas for sine and cosine. So I hope you learned those well, because we'll use those a lot in the next few videos. And in fact, at any point over the next few videos, if you're unsure about how we arrived at some point, you can always prove your way back to where we currently are using the addition and subtraction formulas. So make sure that you know those very well. We will look at a couple quick proofs of these formulas to motivate this and the next few videos. I will give you the formulas themselves and we'll look at a quick example. Write a formula for sine of 2x. Now the question is, since I've said that we can use the addition and subtraction formulas to create a formula for sine of 2x, hence double angle, how might we write this in such a way to make it look like an addition? Well, we can write it just as sine of x plus x, right? Because x plus x is just 2x. And then we can apply our sine addition formula. So we'll have sine x cosine x plus cosine x sine x. In other words, simply, if we rearrange a little bit, we have sine x cosine x plus sine x cosine x, which equals 2 sine x cosine x. Pretty simple proof, pretty simple derivation for the formula, the double angle formula for sine. Now, again, I want to really drive home that knowing your addition and subtraction formulas for sine and cosine are really important. We use that a lot. You can derive the addition and subtraction formulas for tangent, you can derive these, you can derive many relevant formulas, so make sure that you know those well. So the double angle formula for sine of 2x is 2 sine x cosine x. How about for cosine 2x? Well, we know kind of the process now, so let's write cosine of x plus x, and that equals cosine x cosine x plus minus sine x sine x, which equals cosine squared x minus sine squared x. So this is one version of the double angle formula for cosine. Now, if we wanted to write this in terms of sine only, we could remember that sine squared x plus cosine squared x equals 1, which then means that 1 minus cosine squared x equals sine squared x, and 1 minus sine squared x equals cosine x. So let's write this all in terms of sine squared x. So we can substitute 1 minus sine squared x in for cosine squared x minus sine squared x. So this equals 1 minus 2 sine squared x. And this is another version of the formula that we should know. And lastly, we could write it in terms of just cosine. So if we wrote cosine squared x minus 1 minus cosine squared x, that gives us 2 cosine squared x minus 1. And that's kind of the third version of this cosine double angle formula. So again, it's just using the addition formula for cosine and then using our Pythagorean identities to write it in a couple different forms. And then last but certainly not least, write a formula for tangent 2x. So first remember that tangent of x plus y, that equals what? That's tangent x plus tangent y over 1 minus tangent x tangent y. So then it would follow that if we had both angles equal to x, if we had tangent of x plus x, then this would just be tangent x plus tangent x over 1 minus tangent x times tangent x, which then simplifies to 2 tangent x over 1 minus tangent squared x. And that is the double angle formula for tangent. This is all summarized right here. The double angle formulas. Formula for sine is sine of 2x equals 2 sine x cosine x. We have a few versions of the formula for cosine. Cosine 2x, always start with the cosine squared x minus sine squared x, and then it's always easy to get to this one and this one from our first one here. And then the formula for tangent, tangent of 2x equals 2 tangent x over 1 minus tangent squared x. Again, I'll say it once more just for the sake of saying it another time. Your addition and subtraction formula for sine and cosine are really important. Make sure you know those because you can always derive these formulas. So an example. If cosine x equals negative 2/3 and x is in quadrant 2, find sine of 2x. So first, let's write the formula for sine 2x. So we can say that sine 2x, that one was 2 sine x cosine x, right? And look at that, we've already got this cosine x here, as we did in the problem. So we already have most of the information we need. We just need to figure out what the sine x is. And one way we could figure out what the sine x is we can remember that sine x equals the positive or negative square root of 1 minus cosine squared x. So we're putting everything in terms of cosine x here. So now we've got sine x equals this thing, but we have 2, so we need to figure out which one we need to use, whether it's the positive or the negative version of this formula. Well, we're in quadrant 2, and SINE has SIGN sign positive in the second quadrant. So we can get rid of that negative. And then we can say that sine of 2x equals 2 times the square root of 1 minus cosine squared x, which we've got cosine x, that's negative 2/3 squared times negative 2/3. So we have 2, and then the square root of 1 minus 4/9. So, or 1 minus 4/9, which would give us the square root of 5/9 times negative 2/3. So that gives us 2 times negative 2 is negative 4. Square root of 5 is just the square root of 5. And then over, square root of 9 is 3 times 3 gives us 9. So this is one way that we can use the double angle formulas for sine and cosine.